Ally PLM.
Good afternoon. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. Hope everyone is doing well today. I want to welcome all of you to our Ally PLM NX Lunch Byte series. I think most of you that are on the phone with us are aware of what Lunch Bytes are. If you are new, Lunch Bytes are sessions where we cover a topic, a command, or a tool that users may not be aware of. We want our lunch bites to be valuable to everyone, so please let us hear your suggestions on topics that we should cover. If you want to send those to us via email, that's fine. There's also a place on our website where you can suggest a lunch bite topic. If you have any questions regarding today's session, just please write them down and send them in an email. We have several of you on the line with us today, therefore we'll be in listen only mode. And today's topic is on NX Realize Shape. Our goal today is to give you some insight on what is Realize Shape and how to use some of the tools within it. So our agenda, what is Realize Shape? We're going to look at the toolbar and the environment that you go into for Realize Shape, where the preferences are, how to create basic shapes or primitive shapes to start the design, and then we pull and transform those into our complex design, how to turn on symmetric modeling, how to edit subdivision body features, and then we can import subdivision geometry through this .obj format. So what is Realize Shape? In industry, you may have heard of the term of subdivision modeling. Inside of NX, we call it Realize Shape. Subdivision modeling, it's a technique that helps us create advanced shapes. It actually came from the movie industry, and those were the geometry as facets. Then the technology was adapted to suit the manufacturing industry in the form of NURBS or surfaces, or basically real geometry, workable geometry. You start with a primitive shape and pull and tweak it into your desired shape. It's also a great tool for industrial designers for that sculpting clay idea, right? We start with a bunch of clay and start working on the curvature of the design through forming the clay. So Realize Shape, you start with a primitive. In this case, we'll start with a sphere. Notice in the upper left hand corner here, the screenshot, there's something that looks like a cube around the sphere. That's called the control cage. So you manipulate the control cage and that adjusts your geometry. Through the idea of subdividing the geometry into different control faces, then you can pull and tweak and get your desired shape. So we start with a primitive, subdivide the faces, and transform that to get our desired shape. So why look at Realize Shape? It expands the possibilities that can be achieved in CAD. Because it's easy to create these complex shapes, we can create more difficult shapes quickly. You create high quality, smooth flowing shapes, and like I said, it's not easy to do with traditional methods or traditional surface methods or creating all those underlying curves. Because of that, it also doesn't require an expert skill set. And with these complex shapes, with the ideas of additive manufacturing and 3D printing, we can actually manufacture some of these more complex shapes. So using Realize Shape, we can get them a lot easier. Within NX, it's an integrated tool set, meaning Realize Shape is inside of NX. You can still use other NX surfacing and design tools in combination with Realize Shape. For example, we can still analyze a shape. We can, come out of Realize Shape and build a surface using X-form, I-form, and trim our Realize Shape body back. We can then add features downstream, put holes in it, do edge blends, thicken surfaces. We can also use some synchronous modeling downstream as well. Obviously, it's just a body, if you will, so we can put it in rendering and make pretty pictures for our clients. We can take it downstream to NX CAM and downstream for simulation or FEA. So the toolbar environment that we go into, you see here at the top, it's on the surface tab. It's called NX Realize Shape. Realize shape is its own task environment. See the word task there? So it's like you go into your own environment, similar to what you do with a sketch in task, right? I create a sketch, I get on the datum plane to start sketching, and I only have access to sketching tools. When I hit finish, I go back to my, we'll say, regular modeling environment. Same thing with realize shape. When I'm done, I click finish, I go back to my normal modeling environment. There are preferences. Preferences are pretty consistent with NX. You've probably messed with these before. Just how do things look? What kind of feedback do we get as a user to make us more comfortable? So like I said, you start off with a basic shape. So we use a primitive shape command. You have sphere, cylinder, block, circle, rectangle, or torus. I'll make a comment later. Realize shape was new in NX9 and it was enhanced in NX10. So if you're using NX9 and using realize shape, you don't have access to a couple of these types as well as a couple of tools we'll talk about. So just keep that in mind, and I'll make a note of that at the end as well. We can also create basic shapes by extruding a cage. In this case, I already had a primitive, and I'm going to grab that top cage face and extrude it up. Just like you would do an extrude command in modeling, it's just here we're extruding a cage because of the nature of realize shape. We can revolve a cage, so I can take my primitive, excuse me, in this case a circle, and revolve it about an axis, just like we would revolve a sketch or a set of curves about an axis inside of regular modeling. We can loft a cage, so I can go from one section to another section between the cage. You may be familiar with doing a ruled surface or a through curve command inside of modeling, where we're going from one cross section to the other. Similar idea here. We can sweep a section along a cage. You can sweep, you have multiple sections, a maximum of 2 guides, similar to a sweep type algorithm. Here we're doing it with the cage inside of realize shape. Also, you can do a tube cage, so I don't have to have a cross section here. Tube is circular in nature, just like the tube command inside of modeling. So I can say go ahead and apply a certain size diameter cross section along a path. One of the neat things about realize shape is this, that you can start symmetric modeling. When you start symmetric modeling, notice the cage is only on one side of the part, we'll say. So whatever I do to the cage on this side, the other side will mimic because of symmetry. You can stop symmetric modeling if you need one side to not maintain symmetry anymore. One of my favorite commands is this bridge face. I'll go through examples of these a little bit later, but you'll see that if you take a bridge face, we've subdivided this face here, and I say take this face here where my cursor is and go to the face directly beyond it, and notice how it'll bridge that, or basically, you know, make it through there. And because we have symmetry turned on, notice it did the same thing on the left. Fill is similar to like a fill surface or a bounded surface. In this case, we're going to fill inside this cage boundary, this edge boundary. Notice here it does maintain and create a certain curvature. With realize shape, it creates a G2, or C2 if you will, curvature continuous condition. That's important because, as you probably know, using traditional techniques, you have to really be on top of it to maintain that curvature continuous condition. So once we have our shape, we're going to start to transform the cage. We can grab the vertex points, the edge of the cage face, the polygon there, or the cage face itself, and start pulling that into shape. You can think of it as almost like a synchronous tool, but we're directly interacting with the cage, which is adapting to the underlying geometry. We have a project cage. In this case, the example I have here on the screenshot is where I can take something about that cage, whether it's a vertex or an edge, and project it on, in this case, a plane. So I have an offset plane out here in space, and I'm going to project this edge of the cage to the plane to get that result. Delete cage. Delete cage is a lot like delete face. In this case, see how we're going to delete the cage? So it's going to open that up. I have symmetric modeling on, so notice how it did the other side as well. Split face. So there's a couple techniques to subdivide the cage there to make your edits. You can do a split face. In this case, I can pick the cage faces that I want to split. How many number of extra polylines do I want to put in there? So if I do 2, you see that I have 2 around these faces, which would actually divide this one cage face into 1, 2, 3 faces. You can do a subdivide face, which is by percentage. So as I start increasing this percentage, I'll show you this live. What happens is where my cursor here on the boundary where it's orange, it actually starts offsetting, for lack of a better term, another edge in the set of handles to manipulate. Merge face, kind of the opposite of subdivide the face. Here I have these 2 cage faces normal to each other. If I say merge those together, see how I get this angle resultant, and obviously that adapts my geometry. Now I said that everything is G2 curvature continuous inside of realized shape. There are tools where you can set the continuity to either be sharp G0 or smooth G2. At the top screenshot you see that it's set to smooth, so it has that curvature continuous shape. If I change this to sharp, notice how it gives me a sharp edge. If you're not familiar with continuity and you want to learn more information on that, you can check the NX help. You can also check our NX CAD lunch byte on surfacing for more information. I touch on that a little bit there as well. You can also create cage polygon. Really what this allows us to do is create, they're not curves, but I'll call them curves because that's what it's going to feel like, or segments inside a realized shape. Cage polygons can be created or extracted to be used with the creation tools. So what that means, I took cage polygon, I created a horizontal cage polygon, or line if you will, off, and then a cage polygon vertically. Then I did a sweep cage where I took those 2 cage polygon lines and swept them down this path to create my base shape. You can extract a cage polygon. Where this is helpful is if I have some modeling geometry, maybe a sketch or a set of curves that I want to use within realized shape. So when I go into realized shape, I can extract that sketch as a cage polygon. If I go back a slide, then that would allow it to be a path or a guide for the sweep cage in this case. You also have access to construction tools, meaning just your normal studio spline, freestanding point, line, plane, etc. This so you don't have to leave realized shape to create those and come back in there. So just access to construction tools like you would normally use. Now once you get finished using the realized shape tools, you finish that task environment, which you back out of realized shape into normal modeling. What that does is that creates a subdivision body feature. Everything inside the subdivision body feature is, we'll say, history free, right? It doesn't track that we extruded a cage, that we transformed a cage. Alright? But it is listed as a feature here. So here I started off with a sketch, I created a subdivision body. If I did a thicken to that subdivision body, I would see thicken. If I did edge blends, I'd see edge blends. If I did holes, trims, etc., I would see those as features. If I need to actually change the subdivision body, you edit with rollback, and that takes you back into the task environment of realized shape. So you'll see that in action a little bit later. In a note here, you can import subdivision geometry, this wavefront ASCII file. It's a .obj file format. This is just through the normal file import pull down menu, and you'll see Subdivision Geometry, and you can browse that OBJ file and bring that in. So with that, let's go ahead and take a look at some of these examples. So to start off here, I just have a blank brand new part file. So if I come over here to the Surface tab, you'll see here's NX Realize Shape. We go into the Realize Shape task environment. You see the word task up there. If I start here in the Create group, I can start with a primitive shape. Here's the list of what we can create. Like I said, there might be a little bit of difference between NX 9 and 10. It was new in 9 and enhanced in 10. So you see things like spheres, cylinder, block, circle, rectangle, torus. I'll go through a couple of these to give you an idea of what they look like. I'm going to start off here with the sphere. Hit OK, and here's where I was telling you something that's very handy is this Start Symmetric Modeling. If I say Start Symmetric Modeling and I pick the plane, see how it actually builds symmetry into the part. So the cage is only on the near side to manipulate, and whatever we do on the near side is going to happen on the far side because of symmetry. Okay, so if I come in here and do something like an extrude cage, I could grab this face, start to extrude that, and see how it's maintaining symmetry on the other side. I'm going to go ahead and hit undo a couple times just to show you a couple different types of primitives. If I go back into primitive, maybe I'll do a circle this time. Notice the handle we get. You're probably familiar with this, whether it's manipulating datum coordinate systems or the work coordinate system or synchronous or move component. We have that dynamic handle, right? If I want to move something in X, I want to move something in Z, I want to rotate something, right? If I want to rotate that 90 degrees, I could do so with the handle. I'm going to go ahead and put this back flat. So here I have a circle. Now the other thing I want to do is I could have moved that. Let's just do that. Let me hit undo here. So I'm going to create that again. Primitive shape, circle. So I can adjust the size of it. Type in exact values. In here I can find the X translate and say, well, let's move this out in space 4 inches. I can move it X, Y, Z like I was saying. Alright. We look briefly at extrude cage. I can do a revolve cage. Notice I can pick up the edges of the cage. I could have also done these edges as well, but it's just like your typical revolve inside of modeling, right? I'm going to grab something and revolve it about an axis. All right, and I have an angular extent in this case. So I can revolve a cage. Jumping ahead a little bit, you'll see there's a fill command, and if I go to fill and pick up this boundary, it's just like a fill surface or a bounded plane inside of NX modeling. I can go ahead and close that up, but notice how it builds the curvature when it closes it up. Now I haven't done anything with symmetry, so notice I have kind of this one shape on the right and this shape on the left. If I go in even now and do Start Symmetric Modeling, see how there's a switch side? So right now my blue arrow is pointing towards the right. What that means is the left side is going to match the right side. If I hit undo and I say Start Symmetric Modeling and I flip that direction so the arrow's to the left and I hit OK, notice how the right side matches the left side, and the left side is the side that has the control polygon, the control cage. So the symmetric tools are very, very powerful. Okay, I'm going to go ahead and hit undo and talk about another primitive shape here. So let's go to primitive shape. This time I'm going to do a rectangle. Let's keep that as default. I'm going to go ahead and do another primitive shape, and let's do a circle. And I'm going to go ahead and move this in X2 and Y2 to kind of center it up over that rectangle. I'll make the size of the circle a little smaller, and we'll also move it up a little bit, maybe, let's see, 3 inches or something. So these are the inputs. So I could even do something like a lofted cage. Like I said earlier, if you're familiar with doing through curves or through curve mesh or anything like that, we're going from section to section. So if I pick these two edges, I can do add new set and say go ahead and loft it to those two edges. Now when I hit OK, notice how it once again builds the curvature, trying to maintain that curvature continuous condition. We'll talk about it more as we go, actually a lot, being able to transform the cage. I can pick edges. I'm just going to hold down Control. And manipulate those, pull those up. Like I said, it kind of feels like synchronous, but instead of directly interacting with the face, we're interacting with the cage that manipulates the face. I could also grab just vertex points, and you'll see that it's kind of like molding clay into shape. Let me go ahead and undo this back to the start again and show you some other items here. If I come in here and start with, let me do the sphere again. And I'll go ahead and start symmetric modeling once again. And I want this cage to be a little wider, so I'm going to extrude this cage face out to the right. Now we're going to look at this a little more in the next example, but if I come in here and want to divide this up to give it more control, I can come up here and do either a split face or subdivide face. In this case, I'm going to do a split face. I'm going to grab this face and say that I want to split this 2 lines. And I'm going to use this edge as a reference. So those 2 lines come across here, which is actually dividing that face up into thirds. I'm going to repeat the same thing on the face across from it. So we match. And once again, what I do on the right, it's automatically doing on the left because of symmetric modeling. One of my favorite commands inside of Realize Shape is this bridge face, where I can say just take this face and bridge it to this face. So what it does is it bridges them or touches them, and because I have symmetry, it also did the same thing on the left. So that's pretty neat. You can quickly get some kind of handle, for some kind of consumer product like an iron or a vacuum cleaner or whatever it may be. When I click Finish, that's going to leave the Realize Shape environment, and see how it creates this subdivision body. So if I need to go back in there, I just right click, edit with rollback, and I can get right back into my tools and continue to manipulate that shape. We'll talk a little more about that in a minute. Let's go ahead and get into something a little different. Here I have an example. This is actually an assembly. And whether we create another part inside of here or I create some geometry here within the assembly, I have the frame of this race car, and I want to go ahead and start trying to create a body, concept the body of it. So once again, I'm going to go into Realize Shape, and I'm going to start off with a primitive shape. In this case, let's start off with a sphere again. Pretty common. If I look, I can come up here and start to transform the cage like we did a minute ago. So I'm going to pull this out a little bit. And in this case, I have the background assembly to help me reference how big this body and where this body needs to tweak its shape as we go. I want to start the symmetric modeling so I have the same on the right as the left as we create the body. Now right now we just have kind of this hot dog shape or whatever you want to call it in there. We want to manipulate it a little further. I'm going to go ahead and transform the cage to the right here. Just kind of make it a little wider. I'm going to come up into the tire a little bit. It's looking a little better. It still just looks like a blob shape in there. Now I want to start to subdivide the faces and give myself more control how I'm going to manipulate this. So if I come up here and I'll pick on split face again, I'll do subdivide face here in a minute, and I come across and grab these 3 faces that I want to split, and I'm going to do number 2 again. It's going to put 2 dividers in there, so I'm basically splitting these faces in thirds. I'm going to hit apply, and I'm going to repeat for the other direction. I'm going to increase this to 3 and use this as a reference. So now that those faces are split in quarters, right? 1, 2, 3 lines, so that's split in quarters. So what I'm doing is I'm further defining my cage to give me more control to manipulate this subdivision body. So if I come up here and start to transform, I can window select around handle points and start to push that into shape. Maybe I want to window select around here on the very tip of the nose and start to pull that out and try to start to get the shape of the nose of the race car. Also, maybe I need to start creating a little bit of downforce and some aerodynamic characteristics. So I'm going to go ahead and add control and grab multiple, in this case, cage edges. So I've grabbed 3. I didn't grab the bottom because I want the bottom to stay kind of, we'll say, flush for now, horizontal. But I want to pull those 3 down. And because I have symmetric modeling turned on, what I'm doing to the right side, I'm getting for free on the left. So starting to get a little bit of dome shape there. Now right now I haven't positioned this. In this case, just trying to get my concept in here, so I'm just going to transform all this over. So I can just window select everything, and I'm going to center this guy where it should belong about the tire. Maybe pull it up off the ground a little bit. That looks a little better. So that's starting to look a little better. It's still just a blob, but we start to get a little bit of the dome on the very front of the car. Now if I come in here and transform this, I'm going to need a little bit of height to clear these tires. So as I pull that up, once again, see how symmetry is helping me with the other side. Now the other technique to subdivide faces is by percentage. So if I come in here and say I want to subdivide these faces, now the reason why I'm picking these particular faces because I need to be able to transition or flare a little bit around this fender. So notice as I drag this, it's actually, I don't want to call it an offset, but it's kind of like it's offsetting more handles inside the cage by percentage. I'm going to go ahead and subdivide these faces once again to give me further control so I can flare out that fender. And I'll drag those in quite a bit. That looks pretty good. Now, it's a very simple tool. It's kind of like delete face inside of synchronous. If I do a delete cage, it's going to go ahead and open up those cage areas. Yes, I could window select. I'm just showing you exactly what I'm picking. So that opened up around the fender a little bit, as well as opened up the bottom, because it's going to be shelled somehow to create maybe a fiberglass body, and then I'll have to thicken it later. If I look at this from a front view, I can use transform and do a window select type idea where I need to stretch this, maybe make it wider or more narrow. I need to push this in and make it a little more narrow. Maybe now I need to start flaring the fender out. So I'm just holding down control to grab multiple faces in this case. Right, notice how it's starting to transition that out and pull that out. I could exaggerate it so you can really see what we got going on, but I'm going to pull it back more realistic, close to the tire. Maybe I also want to transform here at the front of the car, kind of give it a little bit of a lip here, help with some downforce. And now you're really starting to see the shape, or really starting to see it take shape. I'm going to go ahead and extrude the back of the cage for the length of the car. Maybe I want to go ahead and transform this guy for the back of the body. I'll window select all the handles over here on this side to make this wider. And you get the idea. The workflow is we're going to start with a primitive. Do we want symmetry? transform the cage. Right? Merge, divide, subdivide to give more control, and start grabbing clay, if you will, and molding it into shape. If I hit finish, that's going to back me out of realized shape, and I have that subdivision body once again. Now if I look at this, I forgot to open up the rest, right? I opened up the front part, but when I extruded everything back, extruded the cage back, I forgot to open that up. So I need to go back in to this subdivision body feature with edit with rollback, and that just takes me back into realized shape, and I can do my delete cage, and it's still maintaining the symmetry because that symmetric modeling is on. So now we're back out there. So notice the curvature. Maybe to help highlight the curvature a little bit, we'll throw this in a scene, do a little bit of rendering. And what I'll do is I'll just pull one of the standard scene setups. So different lighting studios and so forth. So you see the lights showing the curvature around there. Maybe if I apply a different material for the rendering, might be able to see that a little better. So anyway, you see the curvature that we created, and it really allowed us to push and pull and get our desired shape. And having this across the assembly, in this case an assembly or any kind of geometry, we can really have a reference for the size and shape of what we're trying to create. So some notes on realized shape. Realized shape was new in NX9. Other features were added in NX10. You see the difference between the toolbars there. In NX10 you see the items like loft cage, sweep cage, tube cage added. The cage polyline, extract cage polyline, as we mentioned earlier. And also keep in mind everything's G2 curvature continuous. Some guidelines when using NX realized shape: keep your control cage as simple as possible. This really isn't anything new when we talk about complex shapes, meaning even whenever you build surfaces and you have your underlying spline curves, you want to create the order or keep the order of those curves as low as possible. Only give yourself as much control as you need. You can use quadrilateral polygon control cages as much as possible. Use split or subdivide as much as possible to create those transitional shapes and feature lines. So whereas trying to flare out the fenders, I did subdivisions to build that transition. Use set weight and continuity sparingly. Remember, set continuity is where we could change it from smooth to sharp. When setting weight and continuity on a control cage, it's good practice to select edges to avoid accidentally applying weight or continuity to internal face edges when multiple contiguous faces are selected. Right? So it depends on how tight those faces are. You want to be careful how to pick those whenever you're applying continuity. And avoid extruding control cage elements a zero length. So hopefully you got an understanding of what realized shape is. You can always go in and check out the help. One thing that I like to do whenever I'm looking at something new is to go into a command and hit F1 on the keyboard. If your documentation is loaded, it'll take you right to the help page for that particular command. As always, our Lunch Bytes replays are on our website. You can go to our website to see upcoming topics, as I mentioned earlier. Our Ally PLM training classes, I didn't put the dates on here. You can go to our website to look up specific dates. Just take a look at what our training offerings are. We do have NX version updates scheduled. So if you're moving to NX9 or moving to NX10 or need a combination of those, check those out. Check out those dates. Check out the agendas, and if there's anything that we can do to tweak an agenda, just let us know. All of our classes can also be taught online. Thanks for your time and your attention. Hope you found this session informative. Please email us your suggestions for future Lunch Byte topics. Also email us any questions you may have had during the session. We appreciate your time, and let us know if you have any questions. And thanks, and have a great afternoon.
Ally PLM.